Hi and welcome to this video series on your GMAT quantitative reasoning section preparation. Today's topic is maxima and minima. We'll be looking at some problem solving questions on this topic. So let's begin. So the first question says, what is the minimum value of the expression 1 by x square minus 1 by 2x plus 5 by 4? The expression that's given to us is 1 by x square minus 1 by 2x plus 5 by 4, and we need to find the minimum value. So let's say some constant k is equals to 1 by x. Then how can you rewrite this equation? It is 1 by x square, that means it is k square, minus 1 by 2x, that is 1 by 2 into 1 by x, that is k, plus 5 by 4. Okay, so this is in the form of a square minus 2ab. If you can write it in the form of a square minus 2ab minus plus b square, you can write it in a whole square form. So you can write this as 2 into 1 by 4 into k plus 1 by 4 whole square minus 1 by 4 whole square. We are adding and subtracting the same number, that's why the equation value will remain the same. So this is k minus 1 by 4 whole square minus 1 by 16 plus 5 by 4, which is equals to k minus 1 by 4 whole square. LCM you take it as 16, you have minus 1 plus 4 5s will be 20, which is equals to k minus 1 by 4 whole square plus 19 divided by 20 minus 1 is 19 divided by 16, which is so this whole square, the minimum value that it can take will be 0. So the minimum value of this equation will be 0 plus 19 divided by 16, which is equals to 19 by 16 is its is the minimum value that this expression can take. That is, answer is option D. Let's look at the next question now. 7x plus 6y is less than equals to 38,000. 4x plus 5y is less than equals to 28,000. A manufacturer wants to produce x balls and y boxes. Resource constraints require that x and y satisfy the inequality shown. What is the maximum number of balls and boxes combined that can be produced given the resource constraints? Okay, we have two inequalities here, that is 7x plus 6y is less than equals to 38,000 and 4x plus 5y is less than equals to 28,000. Okay, we can neither subtract these inequalities or add these. Let's add them and see what happens. It is 11x, 7x plus 4x is 11x plus 5y plus 6y is 11y is less than equals to 38 plus 28 is 66,000. If you divide this whole inequality by 11 on both sides, it will remain the same since it's 11 is a positive number. X plus y will be less than equals to 6,000. So what is the question asking us? What is the maximum number of balls and boxes combined? So that is what, that is x plus y that can be produced given the constraints is x plus y is less than equals to 6,000. So we get the answer as option B. This is our answer. Let's move to the next question now. If the sum of x distinct positive integers is less than 75, what is the greatest possible value of x? Greatest number of possible value. There are x distinct positive integers. So that the number x becomes maximum, we have to see how small an integer, positive integers we can take, so that we can take multiple of them, and the only way of doing that is starting from the smallest positive integer, that is 1, and then followed by the next smallest 2, 3 and so on up till we can find that the sum is less than 75. So, let us just see what is 1 plus 2 plus 3 so on until, let us take a random number, let us say you want to check up till 9. N consecutive positive integers is given as n into n plus 1 by 2. If it is 9, it becomes 9 in 10 divided by 2, which is becoming 45. 45 is way less than 75. You want 75. So, let us next try. If we take n is equals to 9, it is 45. If we take n is equals to say 11, because this plus 10 will be 55, it is still less than 75. If n is equals to 11, it becomes 11 into 12 divided by 2, that is 6, that is equal to 66. If n becomes 12, you just add 12 to 66, it will become 78, which is greater than 75. You want the sum to be less than 75. So, therefore, you will say that n is equals to 11. That means that 1, 2, 3, so on, the sum up till 11 will be less than 75. N is equals to, the greatest possible value of x is 11. Let us look at the next question now. R and S are positive integers, each greater than 1, and if 11 times S minus 1 is equals to 13 times R minus 1, what is the least possible value of R plus S? Okay. We have this equation here, 11 times S minus 1 is equals to 13 times R minus 1, and S and R are positive integers. So, definitely S minus 1 must be a multiple of 13 and R minus 1 must be a multiple of 11 for S and R to be positive integers. So, let us say that S minus 1 is 13, some multiple of 13, some multiple 13k, and let us say R minus 1 is some multiple of 11, that is 11k dash, and then S will be equals to what, 13k plus 1, and R will be equal to what, 11k dash plus 1, and they are asking what is the least possible value of R plus S, that is 11k dash plus 1 plus 13k plus 1. This is 11k dash plus 13k plus 2. We want the minimum, that is the least possible value for R and S. You will have to take k and k dash both equals to 1, because they are positive integers, they cannot be 0. If it is 0, then the value will not be satisfying. It has to be greater than 0. It is positive integers, it is not, it cannot be 0. Okay. So, the minimum value will be when k is equals to 1 and k dash is equals to 1. Therefore, the minimum value of R plus S will be 11 plus 13 plus 2, which is equals to 24 plus 2 is equals to 26. The answer is option E. Let us move to the next question now. If A and B are positive integers and 5A minus 7B plus 3 is equals to 2, what is the least possible value of A minus B? Okay, we are given that 5A minus 7 times B plus 3 is equals to 2. So, therefore, what does it mean? 5A minus 7B minus 21 is equals to 2. So, 5A minus 7B is equals to 2 plus 21, that is equal to 23. But here we are only looking for the value of A minus B. So, let us just see this, how we can split this. 5A minus 7B can be written as 5B plus 2B. So, minus of 7B will be minus 5B minus 2B, which is equals to 23. So, 5 times A minus B, we are taking 2B to the other side, will be 23 plus 2B, and we want the least possible value, that is the minimum value of A minus B It will be when b is minimum, because it is equals to 23 plus 2b. B, what is the minimum value b can take? B is a positive integer. So the least positive integer is when is 1. So when b is equals to 1, you will have minimum of a minus b, that is 5 times a minus b will be equals to 23 plus 2b, that is 2 into 1, that is equals to 2, it's equals to 25. So a minus b is 25 divided by 5, which is equals to 5. So the minimum value of a minus b is 5. What is the answer? Answer is option C. Let's move to the next question now. The sides of a square region measured to the nearest centimeter are 6 centimeters long. Sorry. The least possible value of the actual area of this square region is. So what is the least possible value? They want the least possible value for area which is equals to side square. So therefore we should have the minimum value of side. And what is the minimum value of side that can be rounded to 6 centimeters? Therefore the minimum value will be for side will be what? Will be 5.5, because it is rounded to 6. The minimum value that can be rounded to 6 is 5.5. Therefore, the minimum value of the area, minimum area will be 5.5 whole square, which is equals to 30.25, which is answer option D. So, to calculate the minimum area, we calculated it using the minimum value of the side can take. Let's move to the next question now. From the consecutive integers minus 10 to 10 inclusive, 20 integers are randomly chosen with repetitions allowed. What is the least possible value of the product of the 20 integers? In this we can look at the options. When we look at the options, we can see which one is the least of the possible. They are asking the least possible value. We can see the least of the options is satisfying. We can check it by just checking the answers, and starting from the least value will move our way upwards. So the least possible value is minus 10 to the power of 20 is nothing but 10 to the power of 20, because it is a even power. The minus sign will become plus. So this and minus 10 to the power of 10 cannot be our least value in the options. The least value is not 0 also. It is minus 10 to the power of 20. Minus 10 to the power of 20. Is it possible that we select that integers from minus 10 to 10, 20 integers are selected with repetitions allowed? So you have what? You have 20 integers from minus 10 to 10. Yeah. So if you select minus 10 20 times, you will have minus 10 to the power of 20, which will become a plus 10 to the power of 20, which is not a least value here. We are telling can we get the value of minus 10 to the power of 20? Yes. If you take minus 10 odd number of times and plus 10 even number of times, and since repetitions are allowed, we will take only these two, and when you multiply this, you have total of 20. So that will give you a minus 10 raised to the power of 20 as the required answer, because minus 10, let us just take for an example, to the power of 1 into 10 to the power of 19, because 20 integers are selected, we select 10 as 19 of them and minus 10 as one of them. You will have the product equals to minus 10 to the power of 20. You can try it with another odd number when 10 is raised, minus 10 raised to the power of 3 into 10 to the power of 17, which will again give you minus 10 raised to the power of 20. We are keeping this odd because minus 10 raised to the power of any even number will cancel out the negative sign and make it a positive value, which is not what we are looking for. We are looking for the least possible value, that is minus 10 to the power of 20 is possible. So answer E is our correct answer. Let's move to the next question now. Of the 200 students at college team majoring in one or more of the sciences, 130 are majoring in chemistry, 150 majoring in biology. If at least 30 of the students are not majoring in either chemistry or biology, then the number of students majoring in both chemistry and biology could be any number from. We can do this with a Venn diagram. So we have students who are majoring in chemistry and students who are majoring in biology. And then there are 30 students that there is at least 30 students that are not majoring in either chemistry or biology. Let's say that is y. It is at least that it is greater than equal to 30. Okay, let's say that there are x number of students majoring in both chemistry and biology. Okay, so this area will be what, 130 minus x, because the total chemistry is 130 and the total biology is 150. So this area will be 150 minus x, and the total number of students is what, 200 students. So 200 is equals to 130 minus x plus 150 minus x and plus y. Okay, which is 130 minus x plus x gets cancelled. 130 plus 150 is 280 minus x plus y is equals to 200. Taking x to the other side, you have x is equals to 80 plus y, and we know that y is greater than equal to 30. So we can say this is greater than equal to 80 plus 30, that is 110. So x is always greater than equal to 110. So the minimum value that x can take is 110. And what is the maximum value that x can take? X can take a maximum of only up to 130, because there are 130 students in chemistry. If you take more than 130, the circle comes inside, but there will be no elements left. So the maximum value that it can take will be 130. Therefore, x lies between 110 and 130. There will be no students left in chemistry, so you can only have maximum of the number of students in chemistry, and bio will only be the maximum number of students that are in chemistry, that is 130. So it's 110 to 130. Answer is option D. Let's move to the next question now. If a, b are integers and a mod of a minus b is equals to 8, which of the following is the smallest possible value of a, b? Okay, let's start with what is the smallest value in the options. It is minus 16. Is it possible that mod of a minus b is equals to 8 and a into b will be 16? Yes, it is possible. A minus b can be 8 or a minus b can be minus 8. If you want minus 16 as the product, what is the possible this thing? You can say that minus 2 into 8. Can you add these or subtract these in any way to get 8? We cannot. Or it can be minus 1 into 16. This also is not a combination which is possible. It can be minus 4 into 4. And is this a possible combination? Let's just check. If a is minus 4, minus 4 and b is 4, then you will have minus 4 which is equals to minus 8. Then yes, this is possible. If say a is equals to 4 and b is minus 4, minus of minus 4 will be plus 4 is equals to 8, and this is also a possible combination. So therefore minus 16 is a possible value and it is the smallest amongst all the options. So that is our correct answer. So those were some sample questions on the topic of maxima minima. Hope they were clear. Thanks for watching.